So hi everyone, in this video we are going to discuss about algorithms. So there are many problems that can be solved by considering them as special cases of general problems. For example, consider a problem of locating the largest integer in a sequence. In order for us to solve this problem, we can specify an algorithm, wherein this algorithm will specify the sequence of steps that will be used to solve this general problem. So in this video, we are going to introduce algorithms for two of the most important problems in computer science, that is to search for an element in a list and also sorting a list so its elements are in prescribed order. So how do you actually approach or develop an algorithm? So first thing is to identify the problem that we want to solve, right? So as an example, the one I have mentioned before, the problem of looking for or searching for the largest element in a sequence of integers. Okay, so that's the problem. So what would be the input and what would be the output? So the input would be the set or sequence of integers. Okay, so it's important that we specify legal or valid na inputs. And we also have to specify the desired na output as a function of the input. So if we have specified that what we want to look for is the location of the largest na integer, it means that the inputs should be of integer na data type, not float or not double or not a sequence of characters. Okay, so once we have identified the legal inputs, then we can use an algorithm to provide us the desired na output. Okay, so these inputs or valid inputs will serve as or will be fed to the algorithm, wherein the algorithm will have a sequence of steps to provide us the desired na output. Okay, so here are some of the problems that we can solve. So first is computing the sum of integers on a list. So what would be the input? The input would be a list L of integers, and the output would be the sum of the integers on L. Okay, so if we have considering that all of the inputs are integers, then most likely the outputs will also be an integer. Okay, another problem would be the looking for the common words in two na texts. So the input would be two texts A and B and in English. So we have specified here that the legal input or the valid input should be in English. So suppose that the text is expressed in Kinaraya or Hiligaynon, then most likely that the algorithm will fail because it is not programmed for Kinaraya or Hiligaynon, right? So the output will be the list of common words or words that are both in texts A and B. Okay, so another problem would be finding the shortest path. So a potential input would be a roadmap of cities with distances attached to the roadmap and two designated cities A and B. So the output would be a description of the shortest path between A and B. So how would you get to the how would you get from A to B? So the algorithm can potentially provide that to us, okay? Or ideally provide that to us. Now, how can we solve those problems? So we can find an algorithm. And the algorithm is a finite set of precise instructions for performing a computation or for solving a problem. And the algorithms may be presented using a pseudocode. And since you have already taken COMSA 11, and one way to express an algorithm is by using flowcharts. Okay, so what would be a bad pseudocode? So a bad pseudocode gives plenty of details or is too implementation specific. So in other words, it may be expressed using an actual language like C++ or Java code, or giving every step of a subprocess such as a set union. So this is a bad pseudocode, considering that let's say, you are a team solving some problem. So another one team member does not solve in C++, or another team member does not have any experience with Java yet. So the pseudocode basically is not understandable. So a good pseudocode should have a balance between clarity and detail, and it abstracts the algorithm. So for example, the problem earlier that I have shown, wherein you are looking for the maximum or the largest integer in a sequence. So one way to do that is to sort the algorithm, sort the sequence first, right? So the abstraction means that you don't have to detail or include all of the steps in sorting. You just write sort, okay? And it's already understandable. And it makes good use also of mathematical notation. It is easy to read, and it facilitates implementation. And it is reproducible, meaning the code or the pseudocode may be implemented in Java or C++ or in Python, okay? And it does not hide away important na information. Okay. Now, how do we design an algorithm? So first is we have to understand the problem first. So what do we actually want to solve? Or what kind of inputs do we want? Or what kind of outputs do we want? Okay. And after that, we will be choosing an approach. So should we use a greedy algorithm, or should we use a brute force approach? Okay, so that depends on you. Of course, at this time yet, you don't have any idea what those are at the moment, right? So next, after selecting an approach, you choose the data structures. So should you use arrays, or should you use list or tuples? Okay. Next, we choose a strategy, and in order for us to assess the performance of the strategy, then we have to make sure that it terminates, or your program terminates. All right, and then the program is also complete, and it is also correct. Okay. So finite termination means that an algorithm should produce the desired output after a finite number of steps for any input in the set. So as you have noticed, or in probably in your programming exercises, there are some cases wherein your problem or your code will not, or will just continue looping and will not provide any output. So the tendency is your computer will crash if it continues, right? So it's important that your algorithm terminates, and your algorithm should also be complete. So it provides us all of the desired outputs, and it's important that the algorithm should produce the correct na output values for each of the set na input na values. Now we can evaluate its complexity. So the complexity may be in terms of the time, or the computational resources that is used, or the memory. Okay, so if the algorithm takes a lot of time to run, then it is not ideal, right? So compare an algorithm that executes in 5 seconds than an algorithm that executes in 30 minutes. What would you choose? Okay, and algorithm also should be not memory intensive, or it does not consume a lot of space, right? So now, in order for us to check whether the algorithm indeed works, so we have to implement and test it. And lastly, we can benchmark or compare to other known approaches and algorithms. Okay, so one example would be to find the maximum ni element in the list. So the problem would be, so here's the problem. We have a given set of integers, A with elements A sub 1, A sub 2 until A sub n. So that means that we have n na set of integers. Okay, and question, we want to find the location or the index of the maximum integer A sub I. So from these integers, what is the largest number and what is the location of that largest number? Okay, so what ideas do you have to solve the problem? So a straightforward idea is to simply store an initial maximum A sub 1. So we will assume that the first element is the maximum. And we will compare the stored na maximum to every other element or integer in the set A. Okay, so if we have, assuming that A sub 1 is the initial maximum, then we are going to compare that to A sub 2, to A sub 3, to A sub 4 until A sub n. So we will update the stored maximum if a new maximum is ever encountered. So for example, in cases wherein A sub 2 is greater than A sub 1, then the new maximum will be A sub 2. And that means that A sub 2 will be compared to the next set of elements until we reach A sub n. Okay, so this is the pseudocode for finding the maximum element given those specifications. So we have a procedure max, and the procedure max has an input which is a set of integers A sub 1 until A sub n. So as mentioned earlier, we will assume that the first element is the maximum. Okay, so we will then set max as A sub 1. And then for I equals 2 to n, that means that from the second element until the last element A sub n, we are going to compare the numbers. So if the current maximum is less than A sub I, then or the next element, then we will update the maximum. Okay, so for example, let's say we have the A sub 1 is 0. Okay, and then we will iterate 2 to n. So if max, let's say 0 is less than A sub 2, let's say, which is 1, then that means that we are going to update the max into A sub 2. Okay, and that means that we are going to compare A sub 2 then to every other element until A sub n. Okay, so we can also express it in the form of flowchart. Now, we will discuss about some more algorithms on searching and sorting.